This section is dividing fractions. We're going to look at dividing whole numbers and mixed numbers. So first, recall, division involves grouping. So if I say 8 divided by 2, it means dividing 8 into 2 groups and seeing how many there are in each group, which would be 4. So we're going to determine the quotient, which is the answer to a division question. The quotient. First of all, we're going to look at using a diagram. And as we've seen before, diagrams aren't the best way to look at them, but they can help to visualize. So if I take a 1/3, which is represented here, and I divide it by 2, what I would do is I would cut this thing right in half. And I would say, how many pieces do I have? Well, I have 1 right there. So my total, my answer would be 1 out of, and now I have 6 total instead of 3 because I've cut it in half, right? So I have 1, 2, 3, 4, 5, 6. So 1 out of 6. Let's look at another one. A half, here I have represented here with this diagram, divided by 4. So I'm going to cut this into 4 pieces. So I have a half, cut once, whoops, let's try that again. 1, 2, if I make 3 cuts, you can see I have now 1, 2, 3, 4. I've cut it into 4 pieces. I can see that if I have a half cut into 4, how many am I left with in one section? So now I have 1, 2, 3, 4, 5, 6, 7, 8 total. And I have 1 out of 8 shaded. So that's using a diagram, looking to see, okay, well, what do? I cut this diagram into how many parts, 4, 2, whatever, trying to see how division with fractions work. Good, a decent way to visualize it. So here, as we did before, we're going to come up with a rule. So the rule is the denominator is multiplied by the whole number. If you look at this, see the denominator of 3 was actually multiplied by the 2. The denominator of 2 to get to 8 was actually multiplied by the 4. So we're going to flip the second fraction and multiply. That's the basic rule of division. If the second number isn't a fraction, then like we did before in the previous lessons, always put it over 1. Put it over 1. Okay, if it's a whole number, take that whole number, and you're dealing with fractions, whether you're adding, subtracting, whatever, it's always a good idea to take that whole number and put it over 1. Okay, make the denominator 1. It doesn't change the value, but it will make it make sense in terms of what you're doing, adding, subtracting, getting a common denominator, multiplying, dividing, multiplying the denominators, and so on. So for example, 1/3 divided by 2, I'm going to flip the second fraction. First, actually, I'm going to change that into a fraction over 1. I'm going to take this division, I'm going to actually delete it. I'm going to flip the second fraction. So right now it's 2 over 1. I'm going to flip that. It becomes 1 over 2, right? 2 over 1, I flipped it, becomes 1 over 2. And then I change this to a multiplication question. So I end up with 1 times 1, and 3, which is 1, and 3 times 2, which is 6. So 1/3 divided by 2 became 1/3 times 1/2, which equals a 6. We're going to go through a lot of examples here, so you'll get this idea. So let's go on to the next bunch of examples, which will make this very clear. So part A, 2/3 divided by 3. So I take the 3 is like over 1. I flip that 3 over 1 to make it 1 over 3. And I change this division question to a multiplication question. That simple, right? This is kind of the rule, the method to do it. And then you multiply, which we know how to do. 2 times 1 is 2. 3 times 3 is 9. I cannot reduce that. That is my final answer. Let's go again. 3/5 divided by 6. 6 over 1. Write it over 1 first of all. Flip that fraction, that second fraction, so it becomes 1 over 6. Change that division to a multiplication. And remember that little hint from last lesson? We can like cross divide. So I could actually take this 3 and this 6, divide them both by 3, get 1 and 2. So I get 1/5 times 1 over 2. 1 times 1 is 1, of course. And 5 times 2 is 10. Again, you could have multiplied straight across, reduced after. That's totally fine. 1 over 10. Lastly, 12 over 7 divided by 4. So put it as a fraction over 1. We're going to flip this fraction, so that becomes 1 over 4. And we're going to take this division sign and change it to a multiplication. So flip the second fraction, change it to a multiplication question. Can I reduce anything here? I can. 12 and 4. So 12 and 4 both divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Nothing else can reduce. So 3 times 1 is 3 over 7 times 1, which is 7. Can't reduce that anymore. That is my final answer. Again, you could have gone 12 times 1, which is 12, 7 times 4, which is 28, and then reduce that. You could divide by 2 a couple times. It doesn't matter. That's totally fine. I'm just showing kind of the shortcut. So, one word problem. Flip the second fraction and multiply. A pitcher of juice is 3/4 full. If 6 students share, so you now pour this 3/4 full pitcher into 6 glasses, you're going to try to say or answer what fraction of the pitcher does each student receive. So I start off with 3/4. This is a division question because we're sharing equally. We're trying to see how much that 3/4 of a pitcher divides. So divided by 6, and we're going to do this as a division question. So step 1, put that 6 over 1. Second step, it's a division with fractions, so I'm going to flip this second fraction. It becomes 1 over 6. And I'm going to change that division question to a multiplication. 3 times 1, I'm not going to do the shortcut method this time. So 3 times 1 is 3. You could, though. 4 times 6 is 24. I can divide both these by 3. So 3 divided by 3 is 1. 24 divided by 3 is 8. So each student receives 1/8 of the pitcher. For each student. Okay, so simple word problem there. That's part 1. Again, I combined 2 parts, 5.2 and 5.5, because I think the ideas are very similar. They're so closely linked. So now we're going to divide fractions and mixed numbers. Okay, as we saw before, the mixed numbers are probably going to have to be changed into improper fractions. That's just what we're going to have to do. So just like we did when we're adding and subtracting, or when we're subtracting. So recall the rule. We're going to flip the second fraction and change the division symbol to a multiplication symbol. So just like we did before, this time we don't have to put anything over 1. That's kind of nice. We just flip the second fraction. So 3/4 flipped is 4/3. And change this division symbol to a multiplication. 2 times 4 is 8. 3 times 3 is 9. I cannot reduce that, so that is my final answer. Let's look at another example, this time with a mixed number. So it's going to become a little more complicated. So I see a mixed number. I say, oh no, I'm doing division, subtraction, multiplication. I'm going to have to change that to an improper fraction first. So 1 times 4 is 4, plus 1 is 5. So that changes to 5 over 4. This 3 over 2, I'm going to do all this in one step, so just follow along, please. Hopefully you can follow along. I'm going to flip the second fraction, 2/3, and I'm going to change this to a multiplication question. So first, I change that mixed number into an improper fraction. Next, I flip the second fraction, like our rule says, and then finally, I change the division to a multiplication question. I can see, I'm going to do some cross division here because I'm getting kind of comfortable with this. Divide each by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. 5 times 1 is 5. 2 times 3 is 6. So 5/6 is my final answer for that one. Again, one more example here. 16. This time we have to do 2 things. First, we can change that 16 to a 16 over 1. Because I have to change it to a fraction over 1. Next, I have to change this 1 1/2 to an improper fraction. So I'm going to copy this down here. So 16 over 1, the 1 1/2, 1 times 2 is 2, plus the top is 3 over 2. I haven't flipped anything, so it's still a division question. Now I'm going to flip that second fraction. So it's going to be 2/3. I flipped it. The first fraction remains the same. I change that division to a multiplication. There's nothing in this case that I can cancel. So it just is what it is. So 16 times 2 is 32. Over 1 times 3 is 3. This is an improper fraction. I know that 3 goes into 32 10 times because 10 times 3 is 30. And I'm going to be left with 2 left over. So my final answer is 10 and 2/3. There was a lot going on there. I had to put the whole number over 1. I had to flip the second fraction. And after doing the multiplication, I had to then simplify it back into a mixed number, because in this course, we like to convert improper fractions to mixed numbers. Finally, let's look at 2 word problems. Fairly simple ones. So the first one is, Abraham has 2.5 apples, and Isaac has 3.25 apples. How many times more apples does Isaac have than Abraham? Of course, Isaac has more apples because he has 3.25. So this is how many times more is division. So I take 3.25 and I'm going to divide by 2.5. Both mixed numbers, both have to be changed to improper fractions first before I do anything. So 3.25, so I'm going to take the whole number, multiply by 4, so 3 times 4 is 12. Add it to the top, becomes 13/4. I'm not changing anything yet, we're just keeping this simple. So 2 times 2 is 4, plus 1 is 5/2. Still division. So I'm going to flip that second fraction. I'm going to do the work over here. Flip that second fraction to 2/5. The first fraction remains the same. Change it to a multiplication. I can see that 2 and 4 can simplify. Again, you don't have to do this. You could just go 13 times 2 is 26. 4 times 5 is 20. 26/20, then reduce that. I'm going to reduce it first. So divide by 2. Divide by 2. 13 times 1 is 13. And 2 times 5 is 10. And I can see right away that's it. That's it. That's all I can. Well, it's an improper fraction. So I could change that to 1. But I can't reduce it is what I was trying to say. 1 and 3/10. So you would say that Isaac has 1 3/10 times more apples than Abraham. Okay, so a simple division question, having to change both mixed numbers into improper fractions first. Last word problem. Mr. Howell, it's me again, sleeps for 10 3/4 hours a day. He really likes his sleep. I don't sleep for that long, but man, that would be nice. That'd be beautiful. Awesome. And his son Ephraim, my son is really named Ephraim, he sleeps for 4 1/3 hours a day, which is absolutely nothing, so he's always tired. How many times more sleep, again, division, how many times more sleep does Mr. Howell get than Ephraim? Because I get more. So we start off with the big one, the 10 3/4, and we're going to divide by how much Ephraim gets, which is 4 1/3. Another question where we have to convert both into improper fractions. So 10 times 4 is, of course, 40, plus 3 is 43/4. All I did was change it to improper fraction. I'm keeping the division question for now. 4 times 3 is 12, plus 1 is 13/3. Then I flip that second fraction, so it becomes 3/13. First fraction remains the same, 43/4. That changes to a multiplication question. Nothing cancels here, so we're actually dealing with big numbers, so I'm going to use my calculator. 43 times 3, which is equal to 129, over 4 times 13, which is 52. And then I can see, how many times is 52? I know it's going to go in twice, but 52 times 2 is going to be 104. So I get 2 full 52s going 129. So 129 minus 104 is 25 left over 52. And there's nothing common between 25 and 52 because I know 25 is like, 5 goes into it. So Mr. Howell gets, sorry, my writing is terrible, gets 2 and 25 out of 52, which is almost a half, so almost 2.5 times more sleep than his son Ephraim, who does not get enough sleep at all. You should be getting at least 8 hours a day. That's what they say. So division question, having to convert, again, those mixed numbers into improper fractions, flip the second fraction, and multiply. In conclusion, whole numbers can be given a denominator of 1, like we saw. We could also say improper fraction or mixed numbers need to be changed. I'm going to add that. So change mixed numbers into improper fractions. And then flip the second fraction. Once you've done all that, flip the second fraction and then multiply. So hopefully that lesson helps explain exactly how to divide. Again, it's kind of like multiplication. There's an extra step involved that you have to do, but hopefully it's not too complicated.